Welcome to the Unit 5 review guide videos. This is the second video, and we're going to discuss intermolecular and intramolecular forces. So first thing is, this is a typo. It should say, what are intramolecular forces? Because it asks you to rank them in the second question. So intramolecular forces are the forces between atoms. Okay, forces between atoms in a molecule. Basically, they hold the molecule together. We might think of this as the bond. What are the bonds between the atoms in the molecule? Okay, and there's three bonds that we've learned: ionic, polar covalent, and nonpolar covalent. The strongest of all the bonds is ionic. Then the next strongest is polar covalent. And the weakest of the bonds is nonpolar covalent. Ionics are very strong because you're attracting positive and negative charge like two very strong magnets. Nonpolar covalent has no charges, so they don't have that strong attraction. Intermolecular forces, and how do they compare to intramolecular forces? Intermolecular forces are forces between molecules. And they are weaker. And if you think about it this way, you have to have a molecule before a molecule can interact with another molecule. So intramolecular forces, which hold a molecule together, hold the bonds between the atoms, those have to be much stronger if you're going to have molecules that can actually interact. So you got to have a molecule before you can have interactions between molecules. So intra forces are always stronger than inter forces. Difference between intra and intermolecular force, use a water molecule. So intra is between atoms. It's the bond that holds it together, while inter is between molecules. And hydrogen looks kind of something like this, where you have a partial negative charge and these have partial positive charges. So I could have another hydrogen and oxygen. So again, the hydrogens always have a slightly positive charge. And what I would see is that I would have several of these different orientations depending on what state they're in. Where this bond right here, the dotted line, is an intermolecular force. And it's a hydrogen bond. And here is my intramolecular force, which is a polar covalent bond. So this is my intra. These are the bonds holding my molecule together. These are the interactive bonds between the molecules. So dotted lines always represent inter, and solid lines always represent intra bonds. What tests could be done to look at intermolecular force? Things like melting and boiling points. Okay, conductivity. This is based on if it has ions. If you put an ionic compound into water, it will go into its ion state. It makes an electrolyte. So that would be a sign that you have an ionic bond. Solubility. Again, if you can dissolve it in polar or nonpolar, that gives you an idea of what kind of intermolecular bond you have. Here, melting and boiling can also be involved because you do get interaction between the molecules, and they can have forces that increase or decrease those values. Viscosity, how easily it flows, which we're going to talk about in a second. And then solubility, again, this can be between interactions between what you're dissolving and the material that you're dissolving it in. And we're going to talk more about solutions and solubility second semester. Also, the state of matter. Very strong interactions will put things in a solid state, whereas very weak intermolecular forces will allow your material to go into a gaseous state. So those are some different ways we can look at it. There is some overlap depending on the nature of the forces. Last two topics in this section. They ask us, what is viscosity? Viscosity is the resistance to flow. Okay, it is the measure of resistance of a fluid, and a fluid can be a liquid or a gas, to flow. So for example, if you want to pour out pancake syrup on your pancakes, cold syrup is very viscous. It's going to pour very slowly. Whereas if you heat it up, it is less viscous. So what happens to the viscosity when you heat something? The viscosity decreases because it's actually breaking the intermolecular forces. That's why your hot syrup pours much faster than your cold syrup. So if you can break those forces, it will make the fluid flow much more easily. So on your own, complete the next two tables. The first one gives you all these different types of tests, what forces are involved, could be inter or intra or a little bit of both. Tell what the results are. For example, if you have a very low melting point, that would probably indicate a nonpolar covalent, whereas a very high melting point would be more likely to be ionic. And then in the second table, they give you viscosity in seconds. Basically, how long is it taking to pour, and what does that indicate about the intermolecular forces? Rank them from 1 to 3, where 1 is strongest and 3 is weakest.